Hello and welcome. This video tutorial will serve to help you with the physics homework projectile motion problems. Remember, projectile motion is when an object flies through the air and curves because gravity makes it curve. That means you're going to have a horizontal direction and a vertical direction of motion simultaneously happening. Yet those directions are treated as independent, which means we'll make two separate lists, a horizontal list of variables and a vertical list of variables. Now, one of the things that we learned is that in the horizontal direction, we move with constant velocity. So horizontal will always be a constant velocity list. The vertical, on the other hand, the vertical motion of a projectile is always due to gravity because gravity is what makes it curve back down to the ground, which means in the vertical direction, we will always use a free fall acceleration list. We will basically make a total of 8 variables every single time, 3 for horizontal constant velocity and 5 for vertical free fall acceleration. Every time we will do the same thing. Okay. The differences in each problem, of course, will be the information given. So let's begin. The first problem we're going to look at is called drone delivery problem. Go ahead and click on begin. Now, when you click on this, what you're going to notice is you're going to notice a drone. You're going to be given its speed, and you can see from the position on the thing, you can see how high the drone is above the ground. So we can start listing data. Now, if you click on where it says show question at the top, it's going to tell you, it says determine the height of your object, the bottom of the red ball. The gravitational acceleration on your planet, it's going to give you a value. Please don't assume negative 9.8 if it tells you. Now, if it doesn't tell you anything, we'll use negative 9.8. But on this planet, we're going to use whatever they give you. So in my case, it's negative 8.7. Notice the horizontal speed of the drone. Notice the location of the target on the ground. Okay. Your job is to calculate the time of flight and then the horizontal range, which is the horizontal distance it travels or horizontal displacement. Once we've calculated those, we're going to enter answers in the button. The drone will then release the red ball exactly where we say it will, and we're going to see if we hit the target. Okay, so I'm going to hide the question so we can actually get to work. Oh, let me note my 8.7. Okay. So when we go to the question, do keep in mind, okay, you're going to have, what I'm going to do is I'm going to hide, I'm not, I'm going to hide the question right here. I'm going to draw the path of the projectile. That's how the projectile will look when it's released. Okay. Now, with that said, I'm going to need two lists, horizontal and vertical. So horizontal list is always going to be constant velocity. Those would be 3 variables, delta x, v, and t. However, v is going to get treated as v naught, the initial velocity of release. Since it is horizontal, we will call it v naught in the x direction. So that's the only thing we have to do with projectile motion is we just have to add a x and y direction to velocity and displacement. That's really it. Other than that, we're going to kind of get the same procedures we've done in previous problems. Okay, now you're also going to make a list for vertical free fall acceleration. That's what VFA stands for. Your vertical free fall list is, of course, delta y. Instead of v and v naught, you're going to write vy, v sub y, and v naught y. Okay, you're going to write your acceleration. Now, in my case, the acceleration was negative 8.7. So go ahead and record yours. Okay, negative 8.7 for mine. Okay, and time. Okay, so what we're going to do is we're going to notice some information in the picture that will help us fill out some of the information that we need. Okay, so I'm going to go back to the picture. Notice my drone is at a height of about 2 point, I mean, it's almost exactly halfway between 2.2 and 2.3. So I'm going to say 2.25. I'm going to say exactly halfway. So my displacement, my vertical displacement, delta y, would be 2.25 meters above the ground. So whatever the height of your drone is, go ahead and record that, because that, guys, would be the negative displacement the ball will have. However high the drone is, the ball will have negative displacement of the same amount when it falls. So negative 2.25 meters. Make sure it's a negative because remember, the ball is going to fall when the drone releases it. Okay. Now, let's see what else I know. I know the speed. I can see the speed of the drone. Well, the speed of the drone is going to be the initial speed of the ball when it's released in the X direction. So I'm going to record mine. Now, since it's going horizontally, that would be V naught X. So I'm going to record that as 2.1 meters per second. I think it was 2.1. Yes. Okay, now I think I've got enough to work with. Now, one thing to consider, if my initial velocity, I'm going to do this in different colors. If my initial velocity in the X direction is 2.1 meters per second, remember, for all horizontal projectile motion problems, the initial velocity in the Y direction is always 0. Okay, and think about why that is. Initially speaking, you're only going horizontally. Therefore, you have no vertical velocity to start with. So make sure that for all horizontal projectile problems that we put V naught Y equal to 0. Okay, well, the first thing we're going to do is we're going to calculate the time that it takes to get in the air. So to calculate the time, it's going to depend on what you have. If you have the horizontal distance, then use this equation here. The equation for horizontal distance would be delta x equals V naught x times t. It's your constant velocity equation applied to projectile motion. Okay, but I don't have the displacement here, so I can't really use this equation yet. Okay, but you can see I'm going to need it here in step 2 once I find the time. So I'll keep that in my hip pocket. All right, I already know that the horizontal speed is 21, so I just need to figure out what the time is, and I'll have my horizontal range, my distance. So how am I going to find my time? Well, the time it takes to fall is the same time it takes to go horizontally through the air. Time has no direction. Time in one direction equals time in all directions. So I'm going to use displacement as a function of time. In other words, equation number 9. Delta y equals V naught t plus 1/2 a t squared. But here's the catch. This equation, we just have to put V naught yt. Just like we put V naught xt over here, we have to put V naught yt over here. Now remember, guys, V naught y is equal to 0, yes? So we're going to go and 0 times t, that cancels the whole middle term. And you guys will get delta y equals 1/2 a t squared. Just like you practiced in your free fall acceleration problems, solve for time. Well, you can start by multiplying by 2 and dividing by a. That's a good first step. And you can see I'll get 2 delta y divided by a equals t squared. At that point, I can go ahead and square root. And I think at this point, I can go ahead and plug in my numbers. So t is going to be 2 times my displacement, negative 2.25, divided by your acceleration, negative 8.7. Notice the negatives will cancel, so you really don't need to worry about the negatives at all. And go ahead and calculate yours. I'll calculate mine. So 2 times 2.25 divided by 8.7. Second answer. Okay, I'm looking at about 0.72 seconds that it takes to fall. I'll plug that over here. And 0.72 times 2.1 would give me a drone distance of about 1.51 meters. Okay, so what I'm going to do is I'm going to figure this out. So basically now using this horizontal displacement, I need to figure out the position of where the projectile should be released. Here's what I mean. From my picture, you guys can tell that my target is right on the number 4.51. See that right down here. It's at 4.51. So what I need to do is I need to take that target position, 4.51. I'm going to subtract the delta X I just got, and that's going to tell me where the drone should release the package. Okay, so my position, wherever I'm going to release it, is going to be my the location of where the target is. So in my case, it's about 4.51. Now I'm going to subtract from that my displacement, my horizontal displacement, 1.51. So 4.51 minus 1.51 is conveniently 3 meters. So at the 3 meter mark should be where it gets released. Well, I'm going to go to my program. I'm going to put stuff in and we're going to test this. Okay, so when you're ready, go ahead and enter answers. Okay, it'll prompt you to put your name in first. Okay, my time of flight. Now, time of flight has to be in milliseconds. So that's a good point of contention there. Milliseconds, all you have to do is just move the decimal 3 spaces over because there's 1,000 milliseconds in a second. You essentially multiply by 1,000. So it'd be 721 milliseconds in my case. All right. My release location was exactly at 3. Okay. So what it's going to do, it's going to go through, and when it gets to 3 meters, it's going to release it. And we will see if it hits my target. Right on target. Perfect. Okay, hopefully you guys were able to get that correct and hit the target as well. If so, then let's move on to question number 2. Question number 2 is titled Speed of a Horizontal Projectile. So all the concepts that we just dealt with horizontal projectiles will hold true for this question as well. Put your name in. Let's begin. You're going to click on the zoomed in view of the launcher to fire the ball, and then use the landing location to find the time of flight and the launch velocity. So click on that. Boom. Ball's going to fly through the air. Now you'll notice that my ball is located about 1,201 millimeters. That's 1.2 meters off the ground. So remember, you got to convert to meters, okay? My ball landed 180 centimeters. That's 1.8 meters away. So I got to take all of that information into account to find the initial velocity, that would be V naught X, and the time of flight. Okay, so let me go to my worksheet and I'm going to list some stuff. Okay, my first thing I'm going to list is the height. So 1201 millimeters would be 1.201 meters. The ball lands right there. Okay, that's 180 centimeters, which is 1.8 meters. Okay, so I gotta just put some data in here for step 1. Okay, now the horizontal. Okay, remember you're making a chart of 8 variables, just like we did in the previous problem. So what we're gonna do is we're gonna go. We know that it's 1.8. Okay, we know that the vertical displacement is going to be negative 1.2 in my case, negative 1.201. Okay, this is going to be V naught in the X direction. This is going to be V naught in the Y direction. This is V in the Y. Okay, this is going to be whatever your acceleration is. Okay, now in my problem here, it didn't tell me that the acceleration should be any other thing than on the surface of the Earth, so we are going to use negative 9.8. So if it doesn't tell you otherwise, use negative 9.8. Otherwise, use what they tell you. And I don't know the time. I believe that's what we have to find. Yep, time flight. Okay. All right, so that's a question mark, and that is a question mark. Okay. Well, how about this? Let's do the same thing we did last time. Okay. And to find the time, I'm gonna break this into two parts. So to find time, I'm gonna use displacement as a function of time. So delta y equals v naught yt plus 1/2 at squared. Remember, v naught y was 0. So v naught yt cancels, and I get delta y equals 1/2 at squared. Remember how we solved for time last time? Multiply by 2, divide by a, and square root. So time, right, is the square root of 2 times delta y over the acceleration. So plug into that, guys. We're going to go 2 times, I don't know why I made that so big, 1.201 over negative 9.8. The negatives you see do cancel. Okay, and we're going 2 times 1.201 divided by 9.8, square root that. And I'm getting a time of about 0.495 seconds. Okay, so hopefully you were able to find your time of launch. Now, using that information, you got to now find V naught x. Okay, so if we know that delta x is equal to V naught x times t, all I have to do is divide by t. Okay, and I have V naught x. So V naught x is going to be my delta x. Remember, the ball lands 1.8 meters away, and the time it takes to land is 0.495 seconds. My V naught x, 1.8 divided by 0.495. Let's see, I'm looking at a launch speed of about 3.64 meters per second. All right, go ahead and calculate yours. And we're going to go ahead and enter these values into the program, and we're going to see how we did. And there we go. Okay. Hopefully you were able to get question number 2 correct yourself. If you did, let's move on to question 3. If not, try again. All right, question number 3 is called difference in landing locations. Enter your name into the program. Let's begin. When the trigger is tripped, the ball on the left will fall straight down while the ball on the right will be projected horizontally with the speed shown below. The two balls will be apart when launched. How far apart will they be when they strike the ground? So we got to find the time in the air, and then we have to find the distance. Please note that when you find the horizontal distance of the projectile that's launched, you have to add it to the distance that's given in the problem. So in my problem, it says the two balls are 1.42 meters apart when launched. So you will have to add whatever that distance is to your horizontal distance of projectile. All right. So what I'm going to do is I'm going to list the information given in my problem in the problem. So 10.1 is my launch speed. That would be V naught x. So V naught x is 10.1. Okay. I also know that the height that it's going to fall from is 110 centimeters, which is, of course, 1.1 meters. That means the displacement is going to be negative 1.1 because both balls are going to fall 1.1 meters. Okay, so we're going to we're going to make our two lists. Horizontal constant velocity is delta x. Okay, it's going to be V naught x, and it's going to be time. And then you have vertical free fall acceleration, which would be delta y. I know delta y for me is going to be negative 1.1 because that's how far the ball is going to fall. 110 centimeters is 1.1. Negative because it's falling. Vy, V naught y, which is 0 because the projectile is horizontally launched, And also because the one that is dropped is dropping from zero as well. So both of them have initial velocity of zero. Acceleration, got to double check and make sure that we don't have some other planet here where it's a different acceleration. So we are not told so. So we are going to assume negative 9.8 unless told otherwise, right? And we got to find the time, right? So guess what? We're going to keep using the same property, okay? So to find time, when you're given the height to find the time, you're going to use displacement as a function of time. V naught yt cancels. Delta y equals 1/2 at squared. And what did we do the last few times we solved this for t? Multiply by 2, divide by a, and square root. Okay, 3 easy steps. So we get 2 times delta y over the acceleration, which is going to be 2 times negative 1.1 in my case, over negative 9.8. Go ahead and find your time. I'll find mine. So I'm getting a time of about 0.474 seconds. Now the time it takes the horizontal one, this one here, to land, that's the same time it takes this one to fall. They will fall at the exact same time because time doesn't have a direction. The time it takes to go through the air is the same time it takes to fall down through the air. All right, so now we're going to find the distance. So to do that, first let's find the displacement of the projectile first. So we're going to go delta x times t. Were we given delta x? Yes, 10.1. I think I just forgot to label it right there. So 10.1. Okay, got that. So we're going to go 10.1 times t, which is 0.474. 10.1 times 0.474. We're looking at about 4.79 meters away. Now, that's not my answer because remember, your ball is separated by a distance already. You have to account for that. Okay, so for me, it was 1.42 meters. So I have to remember to add 1.42 meters to that value. Okay, and that's going to be my distance. So my distance is going to be the sum of those two. So 4.79 plus the 1.42 that they're separated to start with, they end up being, in my case, about 6.21 meters apart. Okay. It looks like I was supposed to enter that down here, but that's fine. That is perfectly fine. Okay, I can just move stuff around. Okay, step 5, what do you notice about the height of the two projectiles as they were moving? Okay, well, same height. Same height. Okay, so I'm going to enter in these values and let's see. So I have a time of 0.474. 0.474. And I have a distance of 6.21. Okay, it's going to fly through the air. And you can see both balls are at the exact same height when they fall. And there we go. There we go. I did it good. Hopefully you were able to do it carefully as well and get question number 3 correct. If you did, that's great. Let's move on to question 4. Question 4, landing location of horizontal projectile. So this is the final question for horizontal projectile motion. Go ahead and enter your name in the program. You'll notice you're going to be given the launch speed. So let's record that. In my case, it's 2.23. That's V naught x. V naught x is 2.23. meters per second. You're also going to be given the height for which it's going to fall from. So the displacement of the ball is going to drop, in my case, 956 millimeters, which is 0.956 meters. 956 millimeters, which is 0.956 meters. Okay, and there we go. Okay, so what I'm going to do is I'm going to do some calculations here. Okay, I'm going to figure out where it should land, and that's the landing location and the time of flight. Okay, so there's my list. Delta X, this should be V naught X. Delta Y, this should be V naught Y. This should be VY. This is negative 9.8 because I was not told otherwise. Let me just double check one more time. I don't think it was some other planet. No, nope, nope, 9.8. Okay, we don't know the time. That's going to be our main unknown, and we don't know delta X. So trying to find this, trying to find this. Okay, my delta Y is how far it falls. In my case, it's 0.956. Negative 0.0956 meters. V naught Y is 0 for a horizontally launched projectile, and I don't know what that is. Okay, my V naught X was 2.23. Okay, so again, when you're trying to find the height, so I'm going to be trying to find the height and the time. So I'm going to split this in two. So first I'm going to find the time. Okay, and then I'll find the horizontal distance. So again, what have I been using? I've been using displacement as a function of time. So delta Y equals VYT, V naught YT plus 1/2 AT squared. V naught YT cancels. I'm left with delta Y equals 1/2 AT squared. What is the same way we've been solving for T? Multiply by 2, divide by A, and square root. So time is equal to the square root of 2 times delta Y over A, which is 2 times negative 0.956 over negative 9.8. Put that in your calculator, everybody. 2 times. Notice the negatives will cancel, so don't worry about putting them in your calculator. 2 times 0.956 divided by 9.8. Square root that, and I'm getting about 0.44 seconds for my time of flight. Wrong one. There we go. So I'm getting about 0.0, whoopsie, 0.44. Okay, and then for my horizontal distance, we're going to go V naught X times T. So 2.23 times 0.44. Okay, and my landing distance, 2.23 times 0.44. Let me see. I'm getting a horizontal distance of 0.981 meters. So almost a meter away. Almost a meter away. Okay, it's going to launch, and there you go. You can see it lands almost at a 100-meter mark, which is pretty close to what I calculated, right? I predicted 0.981. It was actually 0.983. Pretty close. Hopefully, you were able to get question 4 correct yourself. If so, move on to question 5. Now, question 5, 6, 7, and 8 are all angle projectile motion problems. Let's see the difference with an angle projectile motion. There's only one extra thing we have to do. Let's see what that is. Finding velocity of a soccer kick. All right, so this one is, we will have a soccer ball, okay, at the bottom edge there. Click on the soccer ball to give it a kick. Based on its flight, determine the velocity, speed, and direction. Let's click on that. It flies. I can see it went a maximum of about 4.1 meters high And you can see it's ending at almost exactly 32 and a half meters away. Okay, so I'm going to take that into account when I put this in here. So it's on the picture. Let's see here. Okay, let's go ahead and I'm going to jot down where it landed. So for me, the soccer ball landed at 32 and a half. So I'm going to go over to that. I'm going to make a mark right there. So that means delta x, right, is 32 and a half meters because that's how far it went. All right. So now what I'm going to do is I'm going to make my list. Okay. So I'm going to make this, I'm going to using the vertical speed of the ball. I'm going to find how fast it was kicked. So let's go focus on our vertical list. Okay. So vertical free fall acceleration has delta y, which it looked to me like it was about 4.1, but I'm gonna hold off on that one. Okay. We have delta y. We have let me see, we have v in the y direction. We have v naught in the y direction. We have acceleration equals negative 9.8 meters per second squared. And we have, did we have the time? Yes, we have the time. So the gravitational field on this planet is 6.0 on my planet. Okay, on yours, it might be different. So make sure you account for that. Okay, 6.0. And you can see I also have a time given of 2.305 seconds. Okay, so my time is 2.305 seconds. Okay. Now, actually, the displacement on this one is going to be interesting because I don't need max height. Displacement, think about this. The ball starts on the ground with an initial position of 0. It lands on the ground with a final position of 0 because it did this, which means what's the displacement? 0 minus 0, which is 0. So since the ball lands at the same vertical position that it started, meaning starts on the ground, it lands on the ground, your delta y, your displacement is actually 0. Okay. Now, if it lands, let's say you kick the ball off a roof. Well, now it's different. Now your ball has negative displacement because it's going to go to the roof, from the roof down to the ground. Let's say you kick a ball on top of a roof. Well, then your ball will have positive displacement because it's going to end up at a position higher than it started. But if it ends at a position at the same level where it started, displacement is 0. So that's nice and easy. Now we're looking for that. Now what I can use, guys, is I can use this equation, displacement as a function of time, but watch how. What I'm going to do in this case, guys, I'm going to set that equal to 0, and I'm going to just solve this. Whoops, sorry. I'm going to solve this equation for v naught y. Now to do that, I'm going to subtract 1/2 at squared, like this. Okay, and then I'm going to divide by t, like that. Okay, and so v naught y is actually going to be negative 1/2 at squared divided by t. So negative 1/2, put in your negative acceleration, minus 6, times your time. My time is 2.305. Don't forget to square it. Okay, and then divide all that by the same amount of time. Okay, put it in your calculator and let's figure out what your V naught Y is. 2.305 squared times 6, take half, divided by 2.305. All right, so I'm looking at a V naught Y of about 6.915. And for now, we're going to keep all those digits. Okay. All right, so now we're going to use the time of flight and the horizontal position to get the horizontal velocity of the ball. Meaning, let's use the horizontal constant velocity set of data. So delta x was 32 and a half. Remember, that's where it landed. V naught x is what we're going to find. And the time is still the same time, 2.305 seconds. So the equation is delta x equals v naught xt. If I divide by t, v naught x is delta x over t, which would be 32.5 meters over 2.305 seconds. So go ahead and divide those and get your v naught x. All right, so I'm getting about 14.1 meters per second. Now, to get your velocity, here's how you do it. See, this is the difference between an angle projectile and a horizontally launched projectile. Go ahead and draw a vector up like this because the soccer ball was kicked up at an angle. Well, we're going to call this initial velocity, and that's what we're looking for. What we just found, guys, is we found v naught x, and we found v naught y. And if you look carefully, all those are the adjacent and opposite sides of a right triangle, which means you're going to use Pythagorean theorem to find the speed, the launch speed, which is going to be the hypotenuse of the triangle. And you're going to use arctangent to find the angle, which is the angle it was kicked at. So let's put in our values. My value for v naught x was 14.1 meters per second. My value for v naught y was 6.915 meters per second. So to get v naught squared equals v naught x squared plus v naught y squared. It's Pythagorean theorem. Square root both sides. And v naught is going to be, in my case, it's going to be 14.1 squared plus 6.915 squared. Go ahead and figure yours out. I'll figure mine out. I'm getting a speed of about 15.7 meters per second. Okay, to get your angle, you're going to use the arctan equation. So it's the y component over the x component, opposite over adjacent. So it's going to be the arctan of 6.915 over 14.1. We'll get an approximate angle there. Make sure your calculator's in degree mode, by the way. 6.915 divided by, in my case, 14 point, oops, I messed that up. Let's see, 6.915 divided by 14.1. I'm looking at an angle of about 26.1 degrees. Okay, I'm going to enter these in my equation, and I'm going to find exactly what it is. So the speed I'm getting is about 15.7. Let me just double check that. Yeah, 15.7. And I'm getting an angle of about 26.1. All right, there we go. Okay, so to find your launch speed and your angle, you've got to find v naught x and v naught y first. Use Pythagorean theorem and arctangent to get those values. Great. Well, if you got question 5 correct, let's move on to question number 6. In question 6, we have a ground-to-ground soccer kick problem. A ball will be kicked with the velocity as shown. Determine the time of flight and the horizontal distance. Remember, you have a different gravitational field, -6. Okay. And I know it says newtons per kilogram, but remember, that's the same thing as meters per second squared. So make sure you record whatever it's supposed to be. Okay. So the first thing I'm going to do is I'm going to draw the information given. I'm going to draw the initial velocity and the angle for which it was done. So that would be, I'm going to zoom in here and I'm going to draw that out. So mine says 15.7. So V naught, oops, sorry, a little big there. Okay, so V naught equals 15.7 meters per second. And my angle is 57.4. Theta is 57.4 degrees. And remember, the ball's down here. Okay, the ball is down there. All right. Now, from this, guys, over to the side, let's go ahead and find our V naught X and V naught Y. Okay. So if this is our V naught, okay. Now in my case, oopsie, in my case, V naught is 15.7 meters per second. So you got to find your V naught X and V naught Y. Well, V naught X is the adjacent side of the triangle. So V naught X is V naught times the cosine of the angle. Remember, the adjacent side of the triangle goes with cosine, doesn't it? Okay, so I'm going to be putting in here 15.7 times the cosine of that angle, which was 57.4. Okay, I'm going to put that in my calculator. 15.7 cosine, 57.4. And I'm getting a speed of about 8.46 meters per second. I'll keep it to a couple decimal places. So that's going to be my V naught X when I do my work. Okay, then I need to find my V naught Y. Your V naught Y is found similarly. V naught Y is the opposite side of the triangle. So opposite goes with sine. So this will be V naught, the hypotenuse, times the sine of the angle. Okay, remember, opposite goes with sine, which would be 15.7 sine of 57.4. Put that in your calculator. Okay, now when I do, I get a value of about 13.23 meters per second for my V naught Y. So that's the first thing you have to do is you have to figure out V naught X and V naught Y for your problem. Okay. Now, oh, okay. So it looks like I was supposed to do that for the part over here. So I'm just going to go ahead and move this down over here. Okay. Now, what I will need in order to do my problem is I'm going to need a list of variables, right? So make your list of variables. Horizontal constant velocity, okay, and vertical free fall acceleration. Okay, so this is going to be what? Delta x, V naught x, which I found to be 8.46 in my example, and time. Okay, then you're going to go vertical velocity. So that's going to be delta y, which is 0. Remember, the soccer ball starts on the ground and lands on the ground, which means it has no vertical displacement. Vy, I don't know what that is. Okay, V naught y, I do know what that is. That is 13.23 in my case. Write down whatever you got in your case. Your acceleration is going to be different than mine. Make sure you get yours. In my case, it's 6. So -6 meters per second squared. And t. Okay, I don't know t. So what I'm going to do is I'm going to solve for time. Okay, I'm going to solve for time. But this, guys, I have a new technique for how to solve for time. Okay. Now, since I have two unknowns for the horizontal part, I still am stuck using displacement as a function of time. But this is how it's going to be different. Write your equation down. Delta y equals V naught y t plus 1/2 a t squared. Since the V naught t term does not cancel, because you actually have a V naught y term here, you're going to solve this quadratic equation. All right. How do we do that? Well, first things first, delta y, that is 0. So I'm going to put 0 equals. Now, this time I am going to substitute. Whenever I have to solve a quadratic equation, I will always substitute the numbers first. This is kind of that one exception to the rule. There's 2 times all year you will plug in numbers. Once during semester 1, that would be this, and once when we start looking at curved spherical lenses and mirrors and doing work with that. So twice during the year, we're going to be plugging in numbers first. This is that one time. So V naught y was 13.23 times t plus 1/2 of negative a, so -6, in my case, times t squared. Well, I'm going to take half of my acceleration and I'm going to rewrite this. I'm going to get 0 equals, not theta, I don't know why I wrote that. 0 equals 13.23t plus a negative is minus 3t squared. All right, now what I'm going to do with this case is I'm going to factor out the greatest common factor. The greatest common factor of this term and this term is a t. There is one factor of t to both terms. So I'm going to factor that out. So I'm going to write 0 equals t. Now, if I factor out a t, what else is remaining? You can see everything else that's not highlighted. 13.23 minus 3t. Now we're going to use the zero product property, the ZPP. What that says is two things that are multiplied and set equal to 0. A, the first term equals 0, and B equals 0. Since you don't know which one equals 0, you set both equal to 0. So this is the first term. I'm going to set that equal to 0. So t equals 0. Well, that makes sense because that's when you launched it. Time equals 0. Now, the second time, I'm going to set that factor equal to 0. Okay, 13.23 minus 3t equals 0. Okay, isolate it. So I'm going to add 3t. I get 13.23 equals 3t. Divide by 3, and you're going to get the time of flight. Okay, so 13.23 divided by, in my case, 3. The time of flight is 4.41 seconds in my case. Go ahead and figure out yours. Now, once you find that, finding your horizontal distance will be fairly easy because delta x equals v naught x times t. So plug in your v naught x minus 8.46 times your time minus 4.41. Figure out your horizontal distance. I get a distance of about 37.3 meters away. I'm going to enter my numbers into the program and see how I did. 4.41 seconds and 37.3 meters. Let's go to launch it. Okay, it's flying through the air. We're going to see where it lands. It's getting pretty close. I think it'll make it. Right on target. All right. So when you're finding an angle projectile, remember to find V naught X and V naught Y first. If you're launching and landing at the same location, we're going to make delta Y equal to 0 because the vertical position does not change. If you got question number 6 correct, let's go on to question 7. We're almost done. We're doing great here. We're almost done. Now we're going to change the vertical position. We're going to kick the ball from the ground and it's going to hit at some height on a wall. Put your name into the program and let's begin. Okay, so similarly, we're going to record our V naught and our angle. So go to your program, start typing that in. For me, it's 18.8. So V naught is 18.8 meters per second. And my angle is 36.6. 36.6. Okay. Now you can see step 2, find the x components of that velocity. So for me, I'm going to go 18.8. I got to find V naught x. And then I got to find V naught y. Okay. So V naught x, oopsie, is V naught times the cosine of the angle. Plug into that. V naught y is V naught times the sine of the angle. Plug into that. I'll plug into mine, you plug into yours. Go ahead and take it to a couple decimal points. All right. Now, when I'm ready to find time and height, I'm going to jump right on to my I'm going to jump right onto my list. Okay, so go ahead and make yours. I'll make mine. Horizontal constant velocity and vertical free fall acceleration. So I've got delta x. I've got v naught x, which I just found mine. List yours. Mine's 15.09. Time, not sure I have that yet. Displacement. We can actually look on the wall, and we're gonna predict how high it gets up. Because remember, we're supposed to find the height, that's gonna be your vertical displacement, and we're supposed to find time. So I don't know time, and I don't know this yet, but this is basically gonna be the height. That's how the height of the ball is gonna be the vertical displacement on the wall where it hits. Okay, Vy, I don't know what that is. Okay, V naught Y, we just wrote that down. In my case, it's 11.21. Believe your acceleration should be given in the problem. Yep, the gravitational field on this planet is 8.5 in my case. So write down yours, negative 8.5 meters per second squared, and time is unknown. All right. So how do we find time in this case? All right. So what we can do in this case is we actually do have something here. Watch. If you look on the picture, you can see where the wall is. The wall is at a horizontal position, so you know where delta x will be. You know how far horizontally the ball will go when it crashes into the wall because you know where the wall is, the front end of the wall. So if I look very carefully, the front end of the wall in my case is at 7 point, man, if I had to guess, maybe 7.8. I don't know. You have to estimate, right? So I'm going to say it's at 7.8. So get this, if I have displacement and I have horizontal velocity, I can find time this way. I can actually use a different way of finding time. So delta x equals v naught x times t, divide by v naught x. You got time by itself. So delta x over v naught x would be 7.8 meters. The wall is away from the ball, divided by your horizontal velocity initially. In my case, it's 15.09 meters per second. Go ahead and calculate your time. I'll calculate mine. I'm getting a value of about 0.517 seconds. Okay. Now, to find the height, you could do this in a couple ways. Okay. You can jump right on the position as a function of time. I would probably recommend that way because you don't know the final velocity on the wall. So this is probably the best way to do it. In fact, I think it might be the only way to do it. So V naught YT plus 1/2 AT squared. If we plug into that, delta Y, my V naught Y is 11.21 times the time I just found, 0.517 seconds, plus 1/2 times A, in my case, negative 8.5, times the same time, 0.517 squared. All right, so what I'm going to do is I'm going to break that down into two parts, and then I'll remember plus and negative, right? I'm subtracting those numbers, right? So 11.21 times 0.517, I'm looking at 5.796 meters. And then on the other side, 0.517 squared times 8.5 equals 2.27. Take half of that, and I'm going to subtract from 5.976, 1.3, no, 1.136 meters. Okay, let me subtract those. 0.796 minus that answer, and I'm looking at about 4.66 meters off the ground should be where the ball hits the wall. Let's find out. My time was 0.517. Okay, it's going to fly and boom, there it goes. It hits right where I said it was going to hit. All right, hopefully you were able to get question number 7 yourself. If you did, on to the last question, number 8. This time we're going to find the velocity in a ground to wall soccer kick. So it's the similar type of problem, but we're going to work it backwards to find the initial velocity. So first things first, click on the ball to give it a kick. You're going to get some data. Boom, you can see exactly how high it kicks and how far it went. So in other words, we know delta x and delta y. Okay. We also know the acceleration due to gravity on your planet. In my case, it's 10. So let's start filling out some data. Okay, so the first thing I'm going to do is I'm going to draw where the wall is. In my case, the wall is at, let's see, 5, 6, 7, 8.3 perhaps. So I'm going to draw the wall. Go to shapes, select a rectangle, and I'm going to insert a rectangle right. Oopsie, that's a very thick rectangle. Let me fix that. I'm going to insert a rectangle about right there. There's my wall. Okay. And then I'm going to go ahead and draw where the ball hits. Okay. The ball, in my case, is hitting just a little bit less than 5 meters high. So if I had to estimate that, that's for, and let's see, 1, 2, 3, 4.5, I don't know, 4.8, 4.8 maybe. But it's hitting about right there. Oops, sorry, it's hitting about right there. Okay, so from there, okay, what I'm going to do is I'm going to list my stuff. So horizontal constant velocity, okay, vertical free fall acceleration. So my delta x, I know it. My delta x is going to be how close that wall is to the soccer ball. Okay, so maybe 8.3 perhaps. 0.3. Okay, so from that, I got to find v naught x. I don't know what that is. Time, I was given the time of flight. So in my case, 0.46 seconds. So 0.46 seconds. So I can use this information to find v naught x. Now on my vertical side, delta y, that's how high the ball was. In my case, it's about maybe 4.8 meters high. Okay, Vy, I don't know what it is. V naught y is what I'm looking for. That's the ultimate thing I'm looking for. Okay, acceleration in my case was -10. List yours. And time, it's the same time, 0.460 seconds. Okay, here we go. So let's find the horizontal speed. That would be V naught x, not just Vx. So I'm going to use that information right there. And I know that delta x equals V naught x times t. So if I solve for V naught x, I divide by time. It's displacement over time. And it would be, in my case, about 8.3 meters over 0.460 seconds. 8.3 over 0.46 is about 18.04 meters per second. Go ahead and keep a couple decimal points on that. Do the same thing. We're going to find V naught y right here. Now to do that, we're going to use our displacement as a function of time, V naught yt plus 1/2 at squared. And you're going to solve it for V naught y. Remember how we did that, guys? We subtract the 1/2 at squared from both sides and then divide by t. Okay, so if I do this, I get delta y minus 1/2 at squared equals v naught y times t. So my last step is just divide both sides by t. I know this equation looks kind of big and ugly, but it's fine. It still works. So v naught y would be, your delta y is how high it was on the wall. So for me, it was about 4.8. 4.8. So plus 1/2 times your negative acceleration, in case my -10. Okay, Oh no, no, it was minus. I'm sorry. It was minus because I moved it over to the other side. So let me fix that. It was minus. And then times your time. My time was 0.460 squared, all divided by um okay. There we go. Sorry, I almost messed that up. We subtracted the 1/2 AT squared. Good, I got that. Squared. Oh, so we got to divide by t. So we're going to divide by 0.460. Okay, now the negative and negative will cancel, so we are going to end up adding at the end here, okay? So let's put that in our calculator and let's figure this out. I have 0.460. I'm going to square it times 10, then divide that by 2. I have 1.058. I'm going to add that to 4.8. And then it equals, and I'll divide by 0.46. That tells me the launch speed in the y direction is about 12.73 meters per second. Now, when I've got that, I'm going to throw those values into my triangle here. Vy, this is actually V not y, okay, is 12.73 meters per second. And V naught x is 18.04. 18.04. And you got to find theta. So remember, to find, we already did this problem. To find V naught, you're going to use Pythagorean theorem. Okay, remember it's the square root of V naught x squared plus V naught y squared. So V naught is going to be the square root of 18.04 squared plus 12.73 squared. Okay, 18.04 squared plus 12.73 squared. Square root that, and we get about 22.08 meters per second as a launch speed. The angle, just use the arctangent equation. Arctangent of my y component, which is 12.73, divided by my x component, my horizontal, 18.04. Arctan, 12.73 divided by 18.04. I'm getting an angle of about 35.2 degrees off the ground. Let's see how I did. Okay, so for a speed, I'm getting 22.07. For an angle, I'm getting 35.2. And there you go. Everything worked out. So hopefully you were able to get all 8 questions correct eventually. I hope you found this video tutorial to be helpful. Remember, if you're still having trouble with it, please come and see me so we can get that worked out for you. Thank you. See you next time.